Hiya. This is an interesting little device which I got a number of years ago in some old junk. I think some of it might have been out of shipping maybe. Anyway, it's got a bit of moisture in it, so it's not working quite as well as it used to, but you can see it's incredibly sensitive to any movement. It seemed to function a bit like a potentiometer, but it actually is a little bit more complicated than that. We've got our meter in series with it, and as I say, when I got it at first it seemed to be a lot more sensitive, so I think the moisture's caused a bit of a problem on it. If I move it, it should give me a plus and minus, but I think it's, if I slow it down, it looks like there's quite a lot of noise on it, so I think there's a problem with it. You can see there's about six cycles per rotation roughly. So it's made by a company, it's a Camille, and it seems to be sensitive to any angular movement. It's no longer produced, this particular one. There's been other ones superseded, but it's worth having a look inside. So see, it looks just like a little cylinder of aluminium. There's two ends to it. I'll open this one as well. And you can see there's a little kind of weight here that moves. There are no electrical connections to this, so that it hasn't any friction, or there's very little friction on its movement. But of course, how does that work? So if we take it apart here, interesting little circuits in here, so it's a little bit more complicated than it first looks. Then there's some adjustments on this as well, though this is soldered in. And seems to be a spacer of some sort here, a spring loaded thing. I think this one comes out as well, lift out. So there's pin connections to connect these boards down through the layers. And the actual mechanisms in here, now I think it's probably capacitive, this one, but I see some of the more modern ones use Hall effect. It has come apart a bit further, and it does look like this is capacitively coupled, so there's no spacer in there and some more connections. So we have plates, and we have a removing plate here. Okay, this is the inside removed from the container. You just have a look at it in a little bit more detail. So from the top, lifting the top part off, it's just really where the connections come into the device. There are two potentiometers for adjustments, and a little hybrid circuit, ceramic hybrid circuit there. We're not quite sure what the components are on that. And that forms this top board, which has an interconnect here to the lower part here. So this one has about 3 ICs in it. So these two are dual CMOS op amps. Not sure what this device is, and obviously some just passive components around that. And if I lift again, connections along the edge that can be removed, and that leaves us with the capacitor unit. So the capacitor unit is formed of 2 or 3 layers here. The top layer has got a number of capacitors effectively on the circuit, and then there's a little impeller here which actually floats. This isn't connected but is free to move. That connects to the counterweight, which is on this aluminium disc here, and the bearing, it seems to be a ceramic bearing. There's no connection from this vein to any part of the circuit. We have a number of etched plates here, and they're all connected to the pins on here. So the 2 pins here connect to the inner and outer plate here. There's one that's floating here with a gap in it, and the outer one will effectively be a casing ground. And similarly, the outer one here's we've got a ground pin here, and there are 2 capacitors. These segments around here are connected to 2 pins, plus the inner part and the outer part form part of the capacitor as well. So effectively what that gives us is a capacitor arrangement a bit like this, and the moving vein, as I say, which is floating, is able to move between there and there, giving us our variation of changes of position. Interestingly, there are 12 segments around there. We're only seeing 6 variations, so it does indicate that there's maybe one part of it not working. Finally, one last interesting part is obviously the counterweight sits on an aluminium disc, and if we look inside the end of the actual outer container, this is a magnet here which is used for damping so that it doesn't just spin freely. So quite a complicated little device to avoid any friction.